For this video, we're going to look at how we can solve equations using the algebraic method. We're going to need to understand that equations can be applied to real-world situations, and we're going to be able to solve a problem using an equation. And to know that we can do that, we're going to look at being able to choose an appropriate pronumeral to represent a value for the equation. We're going to then be able to write the equation using the pronumeral to represent that real world problem, and then of course solve the equation algebraically. So here are some example questions that you might see. So these are all going to be worded questions, which basically represent some sort of real world situation. So the first one says the sum of Jenny's current age and her age next year is 27. How old is Jenny now? So with all worded problems, we need to make sure we understand the problem first of all, and then we have to think about how we can turn this into some sort of equation. So we have something here that we don't know, and that is Jenny's age. So let's create a pronumeral or a variable that's going to represent her age. And it's usually good to use something that sort of makes some sense. So I'm going to use A to represent her age. So A is Jenny's age. And it's always a good idea to note down what your variables or your pronumerals represent. So if A is going to represent her age, at the moment Jenny is A years old. Her current age right now is A. So next year you're 1 year older, so you're going to be A plus 1. So what it is now plus 1 more. So A plus A plus 1. I'm going to put that in brackets just to make it clearer for the moment. So this here is her current age, and this here is next year. All right, so A for current age, A plus 1 represents next year. And we know, because it's told us in the question, that that is equal to 27. So we can look at that equation, we can now solve that algebraically. Before we solve it, we're going to simplify a little bit. So remember, if you've got A plus A, that's the same as saying 2A. And of course, we've still got our plus 1 as well. And that's equal to still being 27. So to solve this algebraically, we need to reverse our operations. So the first thing we've got here that we're going to reverse is the plus 1. So we're going to say 2A plus 1. Now we're going to take away 1 so that we're undoing that plus 1 is equal to 27 take away 1, doing the same on both sides. So that's going to leave us 2A equal to 26. We now need to undo the 2A, the 2 multiplied by A. So that's going to be 2A divided by 2 is going to be equal to 26 divided by 2. And of course, that's going to leave A being equal to 13. And I've just run out of room there a little bit. Now, it's very important that once we have found our value for A, we always want to prove that it's true. So up the top here, I'm going to say if A equals 13, and if our formula or our expression is correct, where we have A plus 1, or we could also use the other version we did, which is 2A plus 1. Either one of those is the same. If we replace A being 13 into those, I'm going to use this second one here. 2A plus 1 equals 27. That's what we have from the question before. So 2 times 13, replacing the A with 13, plus 1 equals 27. 2 times 13, of course, is 26, plus 1 equals 27. 26 plus 1 is 27, equals 27. So that is correct. So we have, in fact, proved that if A is 13, that solves or proves our equation. So we can say that the current age of Jenny is 13. And it is a worded question, so we should try to always provide a worded answer if we can. So Jenny's current age is 13. Okay, so that is solving that. Now, ideally, and unfortunately I just can't do it on this recording at the moment, but these are where we show that we are undoing a step. So there, and when we undo this here, I still would like you to try and show those in a separate color just to make it clear that this is what you're undoing. It's the stage of undoing. So I would try to write those bits in red, but unfortunately in this recording, I'm unable to do that. So do try and do that if you can, please. Okay, let's look at the next one. A pizza and a drink cost $17 together. The drink was $3. How much was the pizza? So again, this is one that you probably can just do without thinking much about it, but let's do it properly and do it algebraically. So the pizza and the drink are 17 together, and we know what the drink is, so we don't know what the pizza's cost is. So that's going to be our unknown variable. So let's use P is the pizza. So P is our variable, our pronumeral, and that's going to represent the cost of the pizza, which we don't know right now. So the cost of the pizza, P, plus the $3 for the drink is equal to $17. Now notice we haven't included the dollar sign in our equation. That's fine, but we have to remember to include the measurement or the dollar sign or the units in our final answer. So P plus 3 is equal to 17. So this is a pretty straightforward one. We're just going to undo the plus 3. So we're going to do P plus 3, now minus 3, so that we undo it. And again, I would like you to write the minus 3 in red or another color. Again, I can't do it in the video. Is equal to 17 minus 3. So that ends up with P equal to 14. So we believe that P for pizza is equal to $14. Let's always check it. So if P equals 14, put it into our equation. So P plus 3 equals 17. So P being 14 means 14 plus 3 equals 17. And of course, that means 17 equals 17. So we have proven that to be true. Of course, it's a worded problem. So the pizza is 14. Don't forget the unit, so $14. If you just wrote 14, then technically you're not fully correct because you need to include the unit. If you wanted to, you could of course put the dollars and cents. Because there are no cents included in this question, you don't really have to show that, I guess. But for absolute completeness, because it is currency, you could show the 2 zeros as well. It's up to you in that case. Okay, this third one gets a little bit more complex looking, but again, if you follow through the steps, it isn't any more difficult. This says that Jim gets $2 every day if he makes his bed in the morning. He also gets $25 at the start of each week to buy his lunch at school. This week he got $33. How many days did Jim make his bed? So we don't know how many days he's made his bed, so that's what we don't know. So let's do B equals bed, all right, just so that we know, okay? And he gets $2 every day he makes his bed, all right? So 2 times B is going to represent how the times he's made his bed. $2 for every B or every day that he makes his bed. He also gets $25 for the week to buy some lunch at the school canteen. So here we have an equation, and we've been told in this particular week he gets $33. Okay? Of course, we'd like to show this a little bit more appropriately. So instead of 2 times B, we should be showing that as 2B plus 25 equals 33. So this equation represents how many times B he got the $2 for doing his bed plus the $25 he gets as well. So again, we're just going to undo these steps. So we're going to undo the $25. So we're going to say 2B plus 25, now minus 25 to undo that. And again, do that in red, please, equals 33 minus 25. Of course, that means we've got 2B equal to, 8. Okay, now we need to undo the 2B. So 2B divided by 2 to undo the multiply by 2 equals 8 divided by 2, which of course leaves us with B being equal to 4. So we believe that he must have made his bed 4 times in that particular week to get $33. Let's check it out. So if B equals 4, all right, our equation was 2B plus 25 equals 33, okay? Replace the B with what we think it is, which is 4 plus 25 being equal to 33. 2 times 4, of course, is 8 plus 25 equals 33, and 8 plus 25 is 33. equal to 33. So, of course, they are both correct. Now, it's a worded question as always. We want to provide a worded answer. So, what is it? Jim made his bed 4 times in this week. Something like that. Okay? And I hope you're noticing that when we prove this on the right-hand side here, it's really, again, basically the reverse of what we did to disassemble it. And where the proof is really important, if we've accidentally made some sort of calculation error, let's say we accidentally divided 8 by 2 and we got 3, if we put b equals 3 in here, we'll soon see that that doesn't work out again. So this is just our proof to make sure that we have, in fact, done all our math on the left-hand side correctly to get to that value. Okay, so it is really a good idea to always do your proof as well. It only takes an extra 30 seconds. You should definitely do it. Let's have a look at one more. Alexa watches some television on Monday, then twice as many hours on Tuesday, and then twice as many hours again on Wednesday. If she watches a total of 10.5 hours from Monday to Wednesday, how much television did Alexa watch on Monday? So again, the most important part of this is to really think about the question. We don't know how much television she watched on Monday. That's our starting point. So T equals television, I'll just write TV, on Monday. It's our unknown. On Tuesday, so we'll start off with T. So T is Monday. Then on Tuesday, she watches twice as much. So T plus 2T. So this first one represents Monday. This second one here is representing Tuesday. All right. And then on Wednesday, she watches twice as much again. Now, be careful. It's twice as much as what she watched on Tuesday. So if you already double it on Tuesday and double it again, that is 4T. All right. So original amount T, double to get to 2T on Tuesday, doubled again to get to 4T on Wednesday. So that's our Wednesday amount. All right. And that is equal to 10.5 hours. Now let's simplify this equation. So if you've got T plus 2T plus 4T, remember these are all additions. So remember from algebra that we can simply add up the coefficients. So you've technically got a 1 in front here, remember. We don't show it, but there's always a 1 in front of any number or pronumerable by itself. So we've got 1T plus another 2 makes 3T, plus 4 more makes 7T. So we can also say this is 7T is equal to 10.5. Okay, now that we've got that, we can simply undo the 7T. So 7T, to undo the 7, we have to divide by 7, is equal to 10.5 divided by 7. And of course, if we do that, we get T being equal to 1.5. Okay, so we reckon it's 1.5 hours. Let's put that in. So if T equals 1.5, our equation was 7T equals 10.5. So we put the 1.5 in. So 7 times 1.5 equals 10.5. 7 times 1.5 is 10.5. So the left and right are equal, so that is correct. So again, a worded question needs a worded answer. So Alexa watched 10.5. Now don't forget the unit, so hours on Monday. I'm hoping you've noticed the mistake that I made. I wrote 10.5, but that was the total. The answer should have been 1.5 that we found, which is our T value. Okay, here we have one more. I think this is the last one for this video. Find the values of X and Y in the rectangle shown. Find the values of X and Y in the rectangle shown. Now, at first glance, we might go, hang on, we've got two unknowns. We've got X and Y. How do we do that? And at this stage, we haven't learnt how to deal with multiple variables, but in fact, we don't need to. It's just going to be two separate equations. So if we look at the rectangle, of course, we know, and we can see it even in the diagram, that this 3y is the same as this side, right? So remember, opposite sides of a rectangle are equal in length. So really what we have is two equations here. We have 3y equal to 6, so this left hand is equal to the right hand, and we've also got this 2x plus 3 being equal to 10, because those two opposite sides are equal. So we've got over here 2x plus 3 is equal to 10. So in actual fact, we've got two separate equations with one unknown in each equation. So we can certainly solve those. So 3y equals to 6, so we have to undo the 3. So we're going to have 3y divided by 3 is equal to 6 divided by 3. So of course that's going to end up with y being equal to 2. Okay, and here on the other side we have 2x plus 3. We have to undo the plus 3 first. We're going to minus 3 is equal to 10 minus 3, which is going to leave us with 2x being equal to 7. Now we have to undo the multiplication by 2. So we have 2x divided by 2 being equal to 7 divided by 2. And of course, that's going to leave us with x being equal to 3.5. And it is always a good idea to put in and do our test, remember. So over here, if y equals 2, then 3y equals 6. So 3 times 2, replacing the y for the 2, is equal to 6. And 6 is equal to 6. Of course, that is true. Over here, for the other side, it's a little bit bigger, so I'm just going to move it up to the side here. So if x is equal to 3.5, our equation originally was 2x plus 3 is equal to 10. So we end up with 3.5, replacing the x value, plus 3 being equal to 10. 2 times 3.5, of course, is 7. Still got plus 3 equal to 10. And 7 plus 3, of course, is 10 equal to 10. And that is also true. So we have confirmed that our x and y values that we found are correct. Now, it is still a worded problem technically, so we should try to include a worded answer. There are no units here. There's no millimeters or centimeters or any other unit measurement, so we don't have to worry about that. But we should still write a worded answer. So we might say the value of x is 3.5 and y is, I want to say 2. Simple as that. Okay, so again, something that looked like it could have been complicated originally because we focus on that there's two values, x and y. We just have to stop, think about it carefully, remember basic things about shapes, being rectangles, opposite sides are equal to each other, and realize that there's actually two equations going on. They're two separate equations that we can solve quite easily. So those are some sample sorts of questions that you might see when applying your knowledge of algebra and solving algebraic equations in real world type questions. So hopefully they are helpful for you. Go back and rewatch them if you need to. But again, the most important part is to identify your unknown first, then to be able to think carefully and write an equation or an expression for it. And then, of course, if it is an equation, so you've got an actual answer at the end, then you can try and solve for the unknown that you have. Of course, you don't always get given the final answer, so sometimes it might just be to work out what the expression is and you can't actually solve it. But in all of these examples, we were given a final value, so we wrote an equation, which of course can be solved. So yeah, rewatch this a few times if you need to, and of course ask lots of questions if you need to as well. Thanks everybody.